Hello students, now we are going to discuss about what are the various issues in code design. We know that the 6 phases of compiler and the last phase is code designing phase. So intermediate code generator is going to generate the intermediate code which is given as input to the code optimizer, which is going to generate the optimized intermediate code that is given as input to the code generator. Okay, so after this code generator, it is going to generate the target code. Clear? So input for this code generator is optimized intermediate code and it is going to generate the target code. So now we are going to discuss about what are the various issues associated with this code generator. Okay, so the various issues associated with the code generator is, first one is input to the code generator. Now the question, what is meaning the input of the code generator? We already discussed that the code optimizer is going to generate the optimized intermediate code as output that is given as input to the code generator phase. So now the question, what is the various forms of intermediate code? We already know what are the various forms of intermediate code. It may be the postfix notation or polish notation. The second one is 3 address code. And the third one is syntax tree, or sometimes we can call as DAG representation. We discuss all these 3 types of forms in various times. We discussed all these 3 in the previous sessions. Come to the 3 address code. Again, there are some 3 types named as quadruples, triples and indirect triples. So depend upon the input code, that means depend upon the optimized intermediate code, the code generator is going to generate the target program. Okay, now come to the second one. The second one is target program. That means by taking the optimized intermediate code, the code generator is going to generate the target program. So now the question, what is this target program? Okay, so here the target program may be of 3 types. The first one is the absolute machine code. The second one is relocatable machine code. And the third one is assembly language. So let us discuss the first one, absolute machine code. So what is absolute machine code? That means if this is my memory, if the program is very small, I am going to allocate the small block of memory for that program. So this is the small chunk of memory. This is allocated to my program at once. That means the contiguous memory is allocated to my program and it is going to generate the program as executable code. So this is comes under absolute machine code. Now come to the second one, that is relocatable machine code. So what is relocatable machine code? So here, if this is my memory, if in various partitions the memory is available, it is going to allocate the memory for my program at this chunk or maybe at this chunk. That means contiguous memory is not there. So it may allocate the memory in 3 different locations. So this is suitable for the huge programs or large programs. So what will happen? After executing this, the linker and loader concept comes under this relocatable machine code. So the linker is going to link all the executable files or the libraries. Then it is going to create an executable file. That executable file is loaded onto the loader and it is going to generate the object code. Okay. Now come to the assembly level language. So this assembly level language is consists the various mnemonics which are not easily understood by us, but if you are writing a program in assembly language, it can transfer to the target code very easily. So the target program of this code generator is maybe absolute machine code, relocatable machine code, or assembly level language. Now let us discuss the third one, that is memory management. So what is memory management? That means we know our compiler consists of 6 phases, and in the 6 phases we can categorize it into front end and back end. So what is front end and what is back end? In our compiler, the entire 6 phases can be categorized into 2 parts, the front end part and back end part. Okay, so both front end and back end has to take care about this memory management. We know there are 6 phases of compiler. So lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, and target code generation. All these phases are linked with the some data structure is known as symbol table. So what is symbol table? What it consists? It consists all the symbols which are written in that particular program. So the output of the lexical analysis, of course the source code is given as input to the lexical analysis. It generates a set of tokens. Depend upon these tokens, this symbol table is filled. Okay, all the symbols what we are using in the program are loaded in this symbol table. So depend upon the symbol table and depend upon the data type or data objects we are used, it is going to allocate some memory. Okay, come to the next one, instruction selection. Now we are going to dealing with this instruction selection. So what is the meaning of instruction selection? Let us say if I had an operation as A equal to B plus C. So no doubt at all, this is the 3 address code form. So for this 3 address code form, if I am dealing with the registers, so what I have to write? First I have to write move this B to some register R1. After that I am going to perform the addition operation as C comma R1, and finally that is moved into R1 comma A. So this is one case. Now come to the second one. For the same instruction only, we can write if A equal to B plus C, first move this B to some R1, next move the C to some R2, then we are going to perform the addition operation. So addition of, you can write R1 comma R2 or R2 comma R1. Then I am going to move this result to A. That means for the same instruction only, here I wrote 4 operations. For the same instruction, here I wrote the 3 operations. So now we can find what is the difference between these two. So if I am dealing with these 4 operations, definitely it increases the execution time and the memory requirements. But here the memory requirements and execution time is low when you compare with this particular model. So we have to efficiently use the instructions. Okay, let us take one more example, x equal to x plus 1. So what you have to do? First I have to move this x value to some register as move x comma some R1. Then I have to perform the addition operation between hash 1 comma R1. So this hash here represents the some constant value. After this addition, the entire value is stored in R1. So I am moving to x as move R1 comma x. So this is the 3 instructions we have to execute to perform this operation. But instead of all these 3 instructions, if you are writing increment inc x, which indicates x equal to x plus 1, that means the value of x is incremented by 1. So this is the only instruction is sufficient to perform this particular operation. Of course it is the register operations or register level operations. Okay, but when we compare with these three instructions, this is optimized one. So we have to select the instruction in such a way that where the number of instructions are low, so that the number of addresses we are using are low and the efficiency of the program is increased. Okay, now let us go for the next one, that is register allocation. Come to the register allocation. We discussed a issue as register allocation in issue of the code generator. So in this register allocation, there are two types. Okay, the first one is register allocation and register assignment. So what is the register allocation and what is register assignment? For example, if I am writing there are two registers R1 and R2. In these two registers, we are keeping the values A and B. So we can say that this register R1 is allocated to A and register R2 is allocated to B. Come to this register assignment, which is the reverse of this register allocation. Here we can say this A is assigned to register R1 and this B is assigned to register R2. So which plays a major role while generating the code. If you are going to discuss about the code generation algorithm, so we have to call a register name is or function as gen register or call register. Okay, so while going to generate the code generation algorithm, we are using some function at get register, and we are using two notations as register descriptor and address descriptor. So this register descriptor works on register allocation, and this address descriptor is depend upon this register assignment. Let us say if there is a code as T equal to A plus B. So this is the 3 address code. For this 3 address code, if I am going to generate the particular code by using the code generation algorithm, I have to use the registers, and if I am writing move A comma R1. So in the register descriptor, I have to write this particular R1 register is allocated to A. In address descriptor, I have to write the value A or the variable A is assigned to R. Okay. Now come to the next one. Let us say move B comma R2. So this R2 register is allocated to B. In address descriptor, what you have to write? This B value is assigned to R2. So this is the way how to assign or how to allocate and assign the values to the registers, and how the registers are allocated to the values. And we are going to use the address management here. And along with this, we are using various addressing modes. Already we learned what are the addressing modes in the computer organization or in the digital logical design. We learned what are the various addressing modes. For example, the addressing modes are direct addressing mode, indirect addressing mode, indexed addressing mode, like this. So depend upon the user's need, we are going to use such addressing modes and these particular register descriptor and address descriptors to generate the code by using the code generation algorithm. In register allocation, we have to find in which way we are going to reduce the usage of registers and in what is the efficient way to use the registers. Let us take an example T equal to some A plus B and T1 equal to some T1 cross D and T1 equal to so T1 by some G. Let us say, so this is my 3 address code. Now I am going to perform the register level operations as for T1. What I have to write? First I have to perform the addition operation. So I am move this A to some R1, then move B to R2. Okay, then I have to perform the addition operation as addition of. So here the values are stored in R1 comma R2. So I am writing R1 comma R2. Then this added value is to be transferred into T1. So writing move R2 comma T1. So here the value is stored in R2. So I am transferring or moving that R2 value to T1. Now come to the next one. T1 equal to T1 into D. So what I have to write? Perform the multiplication operation between T1 and D. Already we know the T1 value here. Then multiplication with D. So D comma some T1. That means I perform the multiplication operation and again the value is stored in T1. Now division of here T1 by G. That means T1 is divided by G. So again I have to perform the division operation as G comma T1. Okay, now that value is stored in T1. So let us say this is the basic example. Let us take this example. T1 equal to A plus B and T1 into D. So first I have to apply the operation as move the value of A to some register R1. Now I have to perform the operation as move B to R2. Now I am going to perform the addition operation. So addition of R1 comma R2. That means here the value added value is saved in R2. Now I am going to perform the move operation as I am moving the R2 value to this particular temporary variable as T1. Now T1 cross D. This is the second instruction. So again I can perform some operation as multiplication of T1 with D. So D comma T1. So the multiplication operation is performed with D and T1 and that value is stored in T1. So this is one way to perform the operation. Now come to the next method. So first I am moving the A value to R1. Now I am going to perform the addition operation between B and A. So B comma R1. That means after performing the addition operation between A and B, that value is stored in R1, which indicates this R1 is nothing but our T1. So no need to move the value to R1 to T1, which is directly indicating that value which is resides in R1 is nothing but the T1. Now come to the second operation. So I am performing multiplication between D comma R1. D comma R1. That means what is the value resides in R1, it multiplied with this particular D. And finally I am moving this R1 to T1. So here we got only 4 instructions. Here we got 5 instructions. That means this is optimized one. So for this only 2 lines of instruction 3 address code only, we are getting 1 line of optimization. But if we go for some 100 lines of code or 1000 lines of code, definitely there is a great impact of this register or register allocations, and we get the efficient code which can increase the efficiency of the program and execution speed of the program. Now come to the last one, evaluation order. What is meaning of evaluation order? In which way we are going to use or evaluate the given instructions. Let us say if T1 equal to some A minus B plus A cross B. Let us say this is my instruction. So first I have to generate the 3 address code for this. After that, I have to execute that 3 address code. That means by using the registers, I have to execute. Now the question, what I have to take first? Here A minus B is there, here A star B is there. As per the associativity, we have to take this only. But in certain case, if there is an operation like A plus B star C, definitely we have to take B star C as the first priority. Then only we are going to execute this. Suppose if the instruction is like A plus B cross C, but here it is parenthesis. So first we have to execute A plus B, then only we have to multiply with this C. So the evaluation order definitely plays a major role while executing the instruction and getting the result. Here the getting the result means nothing but the target code. Okay, so this is all about what are the various issues associated with the code design. Thank you.